Welcome to 4IR. Today we're at the Centre for Scientific and Industrial Research, also known as the CSIR, to visit the Indoor Energy Storage Testbed. Let's meet Thabo Hlalele, the head of the Energy Centre.
Hi everyone, my name is Thabo Hlalele. I head up the Energy Centre at the CSIR, and the role that I perform has to do with coming up with an innovative research solution for energy. And in particular, our major focus has largely been around renewable energy sources, largely because of the inherent benefit that comes with that. Part of the work that we do is aligned across the entire value chain, starting with energy supply, different energy sources that you can find. For example, some of the work that we do is energy meteorology, which really speaks to understanding the resource that we have, be it solar or wind, and we have done a number of work in that space. And other parts of the work that we do speaks to energy systems, which is basically how do you integrate different energy sources to ultimately come up with the pathway that the country can potentially take towards decarbonizing its value chain, and in particular the energy sector. So we do a lot of work within the Energy Centre, and some of that also has to do with the technology development.
Okay, my name is Rinesh Thakurudin. I'm an electrical engineer at the Council for Scientific and Industrial Research, the CSIR, based here at the Pretoria campus, and I lead the Energy Storage Testbed project. My parents were always focused on education and science, and they always bought books for us. We grew up in a fairly disadvantaged background, but my parents never really made us feel like we had a disadvantage. So they did provide many books for us. They prioritized our education. They always tried to surround us with people who we could learn from and who we could grow around. My father had quite a big passion for science, as did my mother. They both had a passion for numbers and science, and it was always around our family that also pursued a lot of scientific fields. One of the first people to graduate in my family is an electrical engineer. So I'm also an electrical engineer. But even further than that, I grew up watching a lot of cartoons and reading comic books. And I always aspired to be like the scientists in those comic books, scientists and engineers like Bruce Wayne, who's Batman, or Tony Stark, who's Iron Man, Reed Richards, Peter Parker. They were all just so inspiring. And in the case of Peter Parker, he was always seen as a nerd. And at the time, before the internet, I was still, even back then, considered a nerd myself. Electrical engineering has evolved quite a bit. If we look at the way electricity has been generated, I grew up in the 90s, so there's been quite a bit of movement from coal technology towards renewable energy. Also, my specialty right now is energy storage and lithium-ion batteries. And I've seen the evolution of these batteries take hold in the marketplace, especially when cell phones became prominent on the market. We noticed how the demand for cell phones increased and how the capabilities increased. And this increased the overall power requirement for batteries. So the energy density for batteries had to increase. And within a lifetime, we've seen leaps and bounds in not only electrical engineering, but in energy storage. Electrical engineering encompasses a large field. My specialty is energy storage, which deals with, like the name suggests, the storage of energy. So in my previous place of work, I worked at a pump storage scheme, and that essentially is an energy storage mechanism. Like a battery stores energy, a pump storage scheme also stores energy. But when we look at electrical engineering, we can look at maintenance, where we maintain certain equipment from the electrical perspective. There's also the high voltage, and then there's low voltage. So when we look at high voltage, we look at your transmission lines. We can design and maintain transmission lines on your transmission networks at a distribution level as well. So your substations, we look at relays, protection side. On your low voltage side, we can also look at your power electronics, which essentially controls your high voltage. So when you look at AC and DC, alternating current and direct current, we can convert it from one side to the other side and backwards. So if we look at renewables, a solar or a PV panel, a photovoltaic panel, will generate power in the form of direct current. Now, most of our equipment in our homes and industry uses alternating current. So we need to convert that to something usable. There's also something referred to as the quality of supply. We need to maintain that quality of supply so that equipment doesn't get damaged. There's also there's been a lot of talk about grid infrastructure, that we need to keep our alternating current frequency constant at 50 Hertz. So electrical engineers play a vital role in actually stabilizing that and actually keeping it in that tolerance level, in that 50 Hertz range. Renewable energy resources, when you look at those, you're looking at energy from the sun, from wind, something that you cannot completely use up. When we look at coal, there's a finite amount of coal on the planet. When that's finished, we are pretty much out of luck at that point. If we look at wind, wind has always been on the planet, and it will be here for much longer than humanity might be. If we look at the sun, the only time we'll run out of solar energy is when the sun dies out, and obviously that will be catastrophic for the planet. So these are resources that we could use potentially for the rest of humanity. Renewable energy is important mostly because it's considered clean. When we burn coal, we produce greenhouse gases, and this contributes to global warming. Global warming and climate change, and we can see today we're constantly hitting record numbers in terms of weather patterns and heat experience or high temperatures experienced on certain days. There are extreme weather patterns across the world with flooding and climate change, global warming. It all speaks to this. So if we can move towards a cleaner grid, more renewable sources, we can actually lower our contribution towards greenhouse gases and global warming.
Welcome back to 4IR. Tabang Mabeo is a physicist and one of the researchers at the Indoor Energy Storage Testbed at the CSIR in Pretoria. The facility equips the CSIR to test the performance and reliability of batteries, as expressed by their storage capacity, life cycle, and depth of discharge. Let's find out more about the team that works with this equipment and what it does.
My name is Tabang Mabeo Ruben, and I'm from Rustenburg. And I studied physics, and I'm a energy storage testbed operator. So I operate the lab. Growing up, I grew up in a very disadvantaged background. My family, I have two siblings. I have a sister and I have a brother. And I grew up without a father, and which was a very difficult situation because I had to grow up seeing my mom struggling to raise three kids at the same time. And it was not easy, but having defined what you want in the future, I think it's what pushed me to be where I am right now. So I started choosing science stream when I was doing grade 8 in high school. And one of my teachers, physical science teachers, his name is Mr. Thomas, he actually used to call me in his office, and we used to discuss things about physics and chemistry. I would mention I was the best performing student, so that's all. So in his office he had a lot of charts and posters about lasers and physics and equations. That always intrigued me, and one thing that motivated me to study physics, specifically to focus on laser science and optics, is actually him talking to me about the study of light and how weird light is. Light can behave as a wave and a particle at the same time. I don't know how that works. So, but that's what actually motivated me to actually study that. In physics, I did industrial physics, which is experimental or applied physics, and then the course that I did actually is in Tshwane University of Technology. So what happened is South Africa had a project. I'm not going to go into details with that, but they wanted to enrich uranium using lasers. So they approached actually different research institutions came together and to develop this course, and they approached different academic institution, and Tshwane University of Technology is the one that accepted this proposal. And the idea was to actually develop a skill with regards to those two fields and enriching uranium with lasers. And this industrial physics has two cores, branches, which is nuclear physics and photonics. And I chose photonics, which is the study of light and application of light, and that's why lasers is a major part of this course. So in South Africa, I would say industrial physics is not yet developed. And when you apply for jobs somewhere and they see industrial physics in your CV, they actually ask themselves, what is this? But yeah, I think it's growing now with regards to looking at the application of photovoltaics, which is actually generating electricity out of light, of which photonics is part of that. And also the fiber optics and in communication, yeah, that plays a role also.
A lithium-ion battery is a form of a battery. There are very many chemistries of batteries, such as lead acid, nickel metal hydride. Lithium-ion batteries are, I wouldn't say very new, they're relatively new. They have been around for a while. And it was just recently awarded, the Nobel Prize was awarded to 3 physicists or 3 scientists in 2019 that actually developed or contributed to developing the lithium-ion battery. So the lithium-ion battery is quite energy dense. It can store quite a bit of energy in a small space, and it can deliver power. So lithium-ion batteries are taking over the market quite a bit. However, I should say there are other technologies still coming into the market. We are seeing things like sodium-ion batteries, solid-state batteries, but at the same time, you're not going to have a situation where it's one technology versus another technology. Each chemistry will have its own place in technologies. So if you look at consumer electronics, you could be using lithium-ion battery, but even lithium-ion can be broken up into several sub-chemistries, 2 of which will be a lithium iron phosphate. Lithium iron phosphate is what you'll find if you buy a battery pack. And then there's another one called lithium titanate oxide, which is much more robust and strong, so you'd be using it in much more harsher environments. So again, it would depend on the direction or the application of the battery, which will dictate the type of battery that you use. So when you look at renewable energy, it's often seen as intermittent. The sun doesn't always shine, the wind doesn't always blow. A lot of the time, we have periods where we could be generating too much electricity from renewables. And if we don't, we have to use energy or electricity as it's generated. The sun will set, and then we need something to bridge that gap, that intermittency gap. So we store energy when we make too much of it, and then we release it when we require it. So it bridges that intermittency when the wind is not blowing or the sun is not shining. An indoor energy storage test bed allows us to test batteries. Not only lithium batteries, but any kind of batteries. We can apply certain load profiles. Like I mentioned, certain applications will have certain load profiles. They work in different ways. They will require more current and voltage at certain times, and we can apply that to the battery and see how it behaves. We can apply and see how batteries perform under certain conditions. We can also increase the temperature. The temperature in the Northern Cape is not the same as the temperature in Pretoria. So we can see how a battery will perform in different temperatures. We also want to provide the services to people who import batteries, assemble batteries, develop new technologies. We want to be part of the community and actually help push the South African community and the larger African continent forward. I have several role models, my parents being one of them. One of them are my deceased cousin. I have a lot of family members who are my role models, but I can also include celebrity scientists like Marie Curie, Albert Einstein, Carl Sagan, Neil deGrasse Tyson, Bill Nye the Science Guy, of course. So I have a wide range of role models and inspirations. Regarding my career, I've faced many challenges. It's not always an easy road, but the idea is to persist and keep going for your passions and always fight for your passions.
My challenge is actually trying to keep up with, reaching out to my goals. Looking back the way I grew up in an area where there's a lot of drug abuse and alcohol abuse, and having to break through that challenge. It has been one of the greatest things actually. So, but one of the challenges that I actually get is trying to give back to the community, but the drug abuse and alcohol abuse has been there as a resistance.
I would say always surround yourself with people you can learn from. When you are surrounding yourself, you can learn. And there's an old saying, if you surround yourself with 4 geniuses, you will be the 5th. So never lose the thirst for knowledge and the passion that you hold. Always be as hungry as you can. Welcome to the Energy Storage Testbed. I'm about to show you our core equipment in the lab. Come with me. Inside here, we have our battery tester. And Tabang will quickly speak to you about the battery tester before we actually go through a quick demonstration.
The battery tester is used only here to charge and discharge the battery. We have 32 channels, and each channel is capable of giving 30 amps and 200 volts. So we connect the battery to the tester for it to charge and discharge the battery, and the power discharged from the battery is sent back to the grid.
So connecting our battery tester with our temperature chamber allows us to test batteries at different temperatures and test their performance under different conditions. Certain batteries will be used in mines, certain batteries will be used along the coast. The temperature will vary quite drastically, and it's important for us to know how this battery will perform under different conditions. So we use our tool equipment to actually give us a good insight into how these batteries work under different temperatures, different conditions, and using that, people can get more out of their batteries and more money out of their investments. With this, we can also provide our consulting services and give more insights on how to better handle your batteries and how to prevent hazards and fire hazards. Its applications are wide. You will find them in your home, in electric vehicles, consumer electronics, in pacemakers, in hearing aids. There's everything. There's space applications, military applications, medical. There's a wide range of applications. Basically anything that's portable, your cameras, your cell phones, anything that you will take around and play music from will all have a battery, will all have a different load profile, will all be applicable to our indoor energy storage testbed. In the future, we hope that we could get more energy dense materials, so we could test this material and get much more energy dense material, and then that would allow us to further bridge the gap of intermittency. A big design consideration in batteries is you want to get the battery as small as possible but be able to store the most amount of energy. A case in point is a cell phone. You want your cell phone to be as light as possible, but that's also limited to the battery. The battery contributes the largest weight. It's the same in an electric vehicle. The battery contributes the largest weight to the battery. If you can get that weight or that volume down, you can increase the range and the performance of the electric vehicle itself. It will shape the future of our country in that it will give us a good footing to move forward. Renewable technology is becoming cheaper, coal is slightly becoming a bit more expensive, and it does have a bit of health effects on the community. Renewable energy will not only allow us to broaden our horizons, it will introduce new technologies to South Africa, introduce new skills, new avenues for employment, and it will help our young, skilled people also gain gainful employment, and it will also push us into a technological advancements in the future.
Being a researcher is actually fun because you get to read a lot and you actually get paid to do that. And one thing that is very weird about being a researcher is actually knowing that everybody says 1 + 1 is 2, but you want to find out, is it really true? Then you end up coming to a point that no, it's not true. And the question is, how do you convince other researchers that actually 1 + 1 is 3, it's not 2? So that's why being a researcher is more fun. You get to think deep, you get to learn a lot of what other researchers have done. Being part of the team in a community is really fulfilling. Giving back to, especially students in high schools, and sharing with them about the importance of physics and the application of physics, and you get to see the people that you encourage get to choose the branch or the field that you actually encourage them to do. It's actually fulfilling.
We share our learnings between each other, same with the community. You get to learn different cultures, how different people find solutions based on their background, their history, and how they are in their culture. So a lot of it speaks to how people solve problems. I might see a solution in this way, another person might see it in that way. And we compare solutions, we see which is the most cost effective, which is the most hard hitting, which will be the most quickest to implement, and which will have the largest impact. And from there we collaborate and we come together in a very amicable way and we move forward together. It's no one being left behind, we always try and move together.
So when I go into the part of how physics plays in a battery, so think about the battery as think about two slices of bread. Okay, you have another part, the anode part and the cathode part. This bread, they are actually sandwiched together. You have other stuff in between. So you have electrodes, which is the anode part. We have another electrode with the cathode part. These materials, there's a lot of physics or chemistry analysis that is going into it. And we have a team in the CSIR that actually looks into enhancing the efficiency of these materials. And you also have a liquid between those electrodes. That liquid is there to enable ions or lithium ions to move from one place to another. So one other part of the electrode, think of a lithium atom. So when you're discharging or when you're charging the battery, you're actually ripping the electron off from the atom, and you have an ion and an electron. Electron will flow throughout the external circuit to power up whatever load that you connect the battery to. And that lithium ion actually needs to move from one side to another. Then it will pass through the electrolyte into the other side of the battery. Hence you have a rechargeable battery. So South Africa, I think South Africa is developing and is adopting a lot of technology. And physics and developing physics skills in the country will help the country to move forward in terms of manufacturing, in terms of coming up with our own technology, and that can enhance the economy of the country.